Taking It to the Streets is all about advancing firefighter safety and operational integrity for the fire service through provocative insights and dynamic discussions dedicated to both the art and science of firefighting and the traditions of the fire service. The focus at Taking It to the Street continues to be straightforward, street-level talk with intelligent, stimulating, and provocative insights and dynamic discussion with interactive dialogue and, most importantly, listener participation. Just like around the kitchen table or in the day room over a cup of coffee at 02:30 after a good run. And now, the latest edition of Taking It to the Streets with your host, Christopher Naum.
Welcome to the newest edition of the Buildings on Fire podcast. I'm your host, Christopher Naum, on your street and your first due. Certainly want to welcome you all for tuning in on this latest edition of our podcast series that we rolled out a couple of months ago, dealing with some insights on the rowhouse building type and rowhouse fireground operations. Much of what we've been talking about over the last few episodes is focused in on certainly the predictability of building performance in this particular building and housing and occupancy type. We laid out some insights on some of the challenges dealing with the highly predictable nature of not only the building type, but also the occupancy type and the occupancy risk associated with such a common type of structure, certainly throughout the North Americas when we talk about the challenges dealing with fireground operations, and certainly some of the significant challenges when we discuss the sacrifice associated with response and operations at these building types. We laid out in our previous episode, actually in our introductory segment, talking about a number of leading issues dealing with these particular building types and as well as their predictability. And I believe that we talked extensively about a number of events leading up to the need for this type of conversation. And these insights, again, when we talk about some of the leading trends, some of the leading issues, and certainly some of the aspects dealing with line of duty deaths and near misses at these particular events. One of the precursors or one of the impetus for getting into this conversation revolved around what we anticipated at that time at the beginning of this past year was the publication and rollout of a very significant line of duty death report that occurred in the city of Baltimore in Maryland, revolving around the triple line of duty death that occurred at 205 Stricker Street, which occurred on January 24th, 2022, in which 3 firefighters lost their lives. It was interesting to note that the significance of that event in 2022, again, somewhat repeated itself in 2023 with another subsequent event that occurred again in the city of Baltimore, this time resulting in a double line of duty death. And that event occurred on October 19th of 2023. We had 2 significant rowhouse events that occurred within a 18-month, 19-month period of time. But that came on the heels of a number of other events that we discussed quite extensively in our first episode when we talked about the NIOSH reports dealing with not only Philadelphia, not only with Baltimore, but with Philadelphia, Wilmington, Delaware, and a number of other events that have occurred around the United States, but especially over the period of time of going back into the 2010 era all the way here to the 2025 period. The last 15 years have presented a number of events that significant lessons and learnings, and we discussed those again in both of our previous 2 episodes on our insights on rowhouse fires. And again, I think when one takes a look at the individuality of these particular reports and then cross-references some of the similarities, and our last conversation that we had in our last episode tried to connect some of those similarities. We talked about some of the aspects of construction, the layout, configuration, some of the precursors that led out to those events. We'll actually get into those a little bit more in detail in our other subsequent programming. We still have 2 other episodes that we are looking to present as part of our series. And in those discussions, we are going to talk about some additional aspects dealing with both the tactical approaches toward these particular buildings, and then also focus in on the command level decision-making process. So our upcoming episodes will include an extended conversation with a number of panelists that we're looking to bring in that will discuss the tactical approach. And then as a second part to that particular podcast, possibly, we will actually get into some conversation dealing with the command decision-making component and reference back out to, again, some of the challenges affecting these particular occupancy types, the occupancy risks, the highly predictability of these particular buildings, and what we can take away to apply to our own first due areas. And that, I think, is the key element here. When we talk about these particular structures, all of you, our listening audience, has a variety of similar or unique row house configurations, construction, impacts dealing with age, deterioration, and more importantly, I want to focus in on this particular program, is some of the unique types of architectural features and construction features that are dominant in your particular area. And with that being said, again, I can go into DC, I can go into Baltimore, Philadelphia, I can go into New Jersey, I can get into New York City, go up the coast into the Connecticut area, Rhode Island area, and certainly end up in the city of Baltimore in Massachusetts. And there are very distinctive, unique features that are specific to the regional applications of these particular buildings that are affected by the age and vintage in which these buildings were built, and are directly correlated back to the methods and the materials of construction that went into those buildings in a particular era of time that are unique and specific regionally to the builders who built the buildings, and the techniques and the methodologies that they brought forward from their place of origin. So when we talk about places of origin, I'm typically discussing the immigrants who came forward in the mid to late 1800s, and with them, they brought techniques, methods, and materials of construction in terms of how these buildings were being built, the methodologies and practices that were being influenced by the country in which they originated from. I'll give you an example here. We're going to talk about a little bit of some specifics that were drawn out of very distinctive methods and materials and processes of construction that were specific to Britain in the late 1800s that made their way into Baltimore City in that time frame that affected the South Stricker Street fire. And in that particular event, there's some very unique things that we researched out that unfortunately did not make their way into the finalized NIOSH report that was recently published. And I'll talk a little bit more about that. But in each instance, there are examples in which the immigrating individuals, the builders who brought forward their techniques and methods and materials of construction utilizing local material. And by that, we're talking about there's distinctive differences in the type of brick, especially the handmade brick that was common in the in that mid to late 1800 period before we got into machine-made brick units and modular units. The type of clay that was drawn out of the soil, this type and species of wood that was drawn out of the forest surrounding these metropolitan or developing cities, whether it be Boston or Philadelphia or Baltimore or DC or Chicago or Denver, or going all the way to St. Louis and San Francisco and Los Angeles. There are very significant and specific, what we call vernacular-based conditions that, again, relate back to the types of woods, the types of clays, and the manner in which these buildings were built. And we'll give some examples here. Our episode on this edition of our row house series is really just going to focus in on some conversation about building construction. And I wanted to just give some insights briefly. This is not going to be a very lengthy program. Again, it's difficult to exemplify and utilize some examples of construction in particular in the absence of visuals. And we were going to look at trying to tie that into a little bit more richer type of podcast and webcasting experience. But for those of you that are just listening in, that certainly would be lost if we had some visuals popping up on the screen that were part of the webcast program. So in the absence of that, we're going to make some referencing to some other documents and some other items that we will make available on both fireengineering.com and then also with some of our accessibility to our social media platforms, both on our BuildingsonFire.com, our upcoming readingthebuildings.com platform that we're going to be rolling out here this summer. But more importantly, we'll try to make some information available to fireengineering.com and get some of those cross-reference. So I made some reference here a moment ago to a couple of reports that just recently came out. So earlier this year, NIOSH was paused. The staff at NIOSH, at the firefighter line of duty program, were dismissed, and the agency was shuttered. In the early part of May or mid part of May, there was a slight resurgence of activity at NIOSH, and a number of reports that were in process of being completed subsequently were very fast-tracked and completed and issued out in a very, very short period of time. Two of those reports, which I'm going to reference to, that we've talked about a little bit in our past episode in terms of awaiting their publication, included Report F 2023-2023-11. This was issued, or it was actually the publication is referenced as of March 2025, and this report that was issued dealt with a double on-duty death that occurred in a single-family row house on October 19th of 2023 that resulted in a double on-duty death in that row house setting. The other report that I'm going to reference to, and again, I've got a lot of notes here in front of me, so for those of you that are watching me live, just bear with me as I work my way through my notations and so forth. But the other report that was published, the publication date is April 2025, and that report actually hit the streets in the middle of May of this year, 2025. So in May, the line of duty death report F 2022-01, and this is in reference to the January 24th, 2023 triple line of duty death at 205 South Stricker Street, which occurred in Baltimore. Although the report is meritable in terms of the information presented, I felt that it fell short of the potential of what was in process of being written and being developed. I had the opportunity to work as a subject matter expert and technical advisor on that particular report and spent about a 2-year period delving into the issues surrounding the building performance, and many other aspects related to what we referenced as an abandoned derelict structure that resulted in the fire department response, subsequent operations, and then very quickly, within the first 6 to 7 minutes of operation, resulted in a very catastrophic, however, very predictable collapse of the entire interior sections of that building, resulting in numerous firefighter injuries, and then subsequently in 3 line-of-duty deaths. So without elaborating too much about that, one of the things that we are going to talk about on our episode here on our podcast is a little bit more insights on some of the construction. There's a couple of features that are common. They're certainly very, very common throughout other related areas in the Baltimore metropolitan area, but also something that I'm encouraging our listeners to think about in terms of identifying features that may be within your buildings as you open them up, as you undergo overhaul and other activities post-suppression. There are many instances in which missed opportunities result, in which building features are not being identified that have very specific and distinctive impacts, not only on that operation, but more importantly on subsequent future operations. And I'll talk a little bit more about that related to another event that occurred at another fire in another city location without elaborating too much right now. But there was another event that led to a double line of duty death, that led to a single line of duty death in another metropolitan city department that became very, very obvious as a result of the building collapse. But it wasn't until we got involved in the re-examination of that building, the identifying building features and conditions, did we find a very subtle feature that had a pronounced effect and result on that event, but more importantly, that other tens of thousands of other similar buildings existed in that particular row, across the street, behind it, on the next block, that had similar building attributes, that had a high degree of building predictability, that now, with them being identified, assessed, number one, identified, assessed in terms of their importance, and then subsequently integrated into training and education of responding companies that could very well have similar types of building features present, that certainly end up influencing the decision making on the fireground. And I'll talk a little bit more as we go into our conversation and into our insights. So let me sort of see where we're at here with some of the information as we get into this conversation. So again, I think the importance of, so I'll say this, right? So the predictability of building performance is always going to be present. It's a matter of understanding key features, inherent, highly predictable features in all buildings, that once we know what to look for as part of our building reads, our size ups, things that are inherent to our first due, our battalions, our divisions, sometimes our entire city areas, we've got to be able to, number one, identify, understand, comprehend, and then more importantly, be able to apply those building features in our subsequent decision-making process, tactically at the operational level, and certainly strategically at the command level. They are important at both of those fluid areas, but even the most important is at the task level, that sometimes gives us go and no-go criteria, highly influences our decision-making tactically, and certainly should very well and very much so influence decision-making at the command level as a subsequent operation continues to evolve. Critical thinking, conservative bias, again, requires a much broader approach to building construction that includes both building literacy and suggested avenues for improved methods and practices. And again, I think we've heard this before when I talk about building literacy, building and fire literacy. The American Fire Service knows enough to get by, but not nearly enough to advance it to this intermediate to the advanced level. So, when we talk about both row house and row frame construction, our conversation in these episodes have really been focusing in on row house construction of type 3, which is our brick and joist constructed features, and really has not gotten into the conversation dealing with row frame construction. Similar in terms of their configuration and layouts, just in terms of appearances. To some extent, obviously the absence of masonry construction is pronounced, but it's certainly the standpoint that we could also have what appears to be a row frame constructed building with some type of wood or vinyl applied siding that has been modified and updated and modernized. But once we get past that facade, especially with adaptive reutilization over the decades of time, we may not really be able to recognize what the building's anatomy, the structural features of that building may be. But first and foremost, again, both of these structures normally revolve around multiple units that are subsequently attached in a longitudinal manner, meaning horizontal, going across, where we have individual occupied units that are attached and share various types of common or separation wall construction. Typically, it's greater than 4 units that are subsequently constructed one after the other in a horizontal or longitudinal manner that typically will make up a half, or more commonly, an entire city block of orientation. So they are adjacent to each other, starting at the street corner And again, it's not uncommon to have 20, 30, or sometimes 40 adjacent units that comprise our rows of occupancies, thus the name row house construction, common to our urban areas. But again, it's also common to find the remnants of significant row house construction, or the remnants of those in a city block or a partial city block, or the middle of the row, where we have 3 or 4 or 5 units that were, let's say, in the middle of the row that are the remnants, and open lots on either side, or sometimes new construction on either side of those particular structures on both the Bravo and the Delta sides. But again, our conversation when we talk about row house, typical brick and joist construction, type 3 construction as classified by the NFPA 220 standard, but also recognized prior to 1952, before we had the advent of the NFPA 220 standard, buildings were classified in a different classification relative to construction materials, even some of the terminology. And I'll leave that for another point of conversation, but it's important to note we actually talked about building classifications in one of our episodes in 2023 and again in 2024, talking about predictability, building performance. I believe we actually got into quite a bit of details concerning how buildings were classified, especially in the late early 1900s. When we got into the 1900 era, between 1900 and 1915, the National Board of Fire Underwriters actually gave us some of the first modeling and some of the criteria that went into the significant unification and consistencies with changes in construction that was related back to how buildings were classified, the kinds of materials that went into the building, and yes, even the degree of some of the suggested fireproofing, which was a very loosely used term at the time, that were attempts to provide fire resistiveness into the buildings based upon all of the significant civilian loss of lives in the mid to late 1800s, as well as the significant property losses that were a result of major conflagrations in these particular buildings. So there was an attempt to provide some degree of fire resistiveness, and that term fireproofing was a very embraced term, and in many instances it was actually disguised as a marketing tool. Sometimes many of you may see the ghost signages on the sides of buildings that says fireproof a building. It was actually in Akron, Ohio. Last year we were doing a training class, and we went into one of the downtown areas near Ohio State University, and right across the street as we were going to our particular venue, one particular building which had been adaptively reutilized had a significant signages that, again, was a ghost sign back from the day of that 1900 period that still had the terminology and in very, very bold letters talked about being fireproof. It was considered a significant safety item, and it was also a significant marketing tool because the public was actually more apt to let or rent a room in that particular area, or to occupy rooms in these quote-unquote fireproof buildings, because they recognize the substantial levels of risk in non-fireproof structures. And although slight in many instances, sometimes that fireproofing only consisted of the application of galvanized metal or tin on both vertical wall areas and stairwells in particular, and then also the fireproofing or the fire separation or resistiveness that was applied to the underside of what commonly was exposed floor joist and ceiling joist to provide some degree of fire resistiveness. So all of this was an attempt to provide resiliency and integrity to the building as a result of what commonly was the events of fire that would occur, and how quickly the fire would propagate and extend both in the compartments, the room areas, but certainly in the concealed spaces within these structures, commonly and typically trapping civilians, resulting in large-scale fires that went beyond the rooms and the buildings of origin. So there's just a little bit of a side note dealing with some insights on fireproofing. Just another quick note when we talk about the row frame, again, that row frame may include heavy timber. It may include both brace frame construction as well as balloon framing. Brace frame is more commonly the type of heavier timber or fully dimensioned lumber. So if we go from heavy timber to brace framing, the brace framing is actually a smaller dimensioned, although fully dimensioned type of framing system, and should not be misconstrued with nominal dimension lumber as we currently have. So when we talk about fully dimensioned lumber, if I talk about a 3x6, it truly was a full 3-inch dressing by 6-inch dressing that provided the structural integrity for the studs that would go into the building or the floor joists. If we dealt with a 3x8 or 3x10 floor joist or a composite beam that was present in the building, that would include a full dimension of 3 by that, whatever that number may be. So when we talk about a 3x10 in the legacy, and again, I hate using the term legacy because it is so inappropriate and very inaccurate. Our terminology for these particular buildings is called heritage construction based upon our building classifications from era and vintages, and is more appropriate. And again, go back, we had an episode where we talked about era and vintage that we first coined back all the way in 2000, 2001. Its relationship back to architecture, engineering, and the basis of all of that. Again, it has become somewhat more institutionalized, and many are bantering around and utilizing the term without clearly having a distinct understanding of what it truly relates back to. So again, for a refresher, many of you have heard the term being utilized by some of the testing organizations and the research that's being published from that talks about modern construction and legacy construction. Everything that's not modern is referred to as legacy, meaning the older construction, but that is just such a significant disservice, unfortunately, because it's very, very inaccurate when we talk about trying to classify and bin all older construction that's non-modern or lightweight engineered construction into one terminology, because there is a predictability, there is a rationale, there is something that ties in very, very explicitly to these different eras, sometimes that span multiple decades of time, sometimes they span 40 or 50 years that are part of our era and vintage modeling, but they do tie in and have a very critical role in both the predictability of building performance, understanding building construction, relating back to size up, reading the building, and so on. But again, I don't want to get into that level of discussion here at this particular point. So when we talk about type, when we discuss row house construction, again, we're referring to both brick and joist or type 3 construction based upon the current editions of the NFPA 220 standard. But both type 3 construction, when we talk about the dominant building features, the walls, configuration, perimeter walls, shared wall areas that may be adjacent to the occupiable units of the row houses individually, and the type of wood frame construction that may be present also. Again, there may be balloon framing, there may be some type of brace framing within that structure, but more commonly there may be some characteristics of balloon framing that's present in both the 2- and 3-story versions of these structures. So again, when we discuss row house construction, it is consistent with both bearing and non-bearing masonry walls, as well as party walls. Those party walls are more common in our row houses. Those are the separating walls between adjacent individual occupiable spaces. So we can have end of rows. So we can have units that are located more dominantly at the end units of these rows on either end of the street. And then commonly it's the middle of the row or middle of the group. So it's end of group, middle of the group. Sometimes those terminologies are interrelated based upon the regional applications that you may be referring to. Some of the other aspects too is that you may find, especially with newer types of row houses or those that have undergone significant adaptive reuse or renovation and alterations, that there may be a hybrid degree of construction, both old construction, the heritage type of construction that was common in the 18 and 1900s, all the way up to the most current standpoint in which the buildings may have undergone some renovation work. And now we've introduced lightweight engineered or engineered structural systems, ESS, as we refer to them, in which there may be a whole variety of different type of structural floor as well as partition systems that are providing both structural as well as non-structural based compartmentation, carrying the spans and carrying the loads within the particular buildings. As I mentioned, commonly when we refer back to row house type of construction, it typically is 4 units or greater. In terms of those rows, typically the footprint extends for an entire block or half a city block, but more commonly when we talk about row houses, they are from one intersection or one street corner to the other, however large and small that street layout may be within your particular city or jurisdiction. But they may very well be rather lengthy in terms of the number of units, commonly anywhere from 20 to 30 to 40 units that comprise the rows that are common to these row houses. The row houses may include both commonly 2 or 3 story. Those are the most common. There are some 4 stories, but now we start moving from row houses to townhouses in terms of some of that construction. But there are some slight nuances that may be present that are very much geographically based upon where you're at across the United States. So for some of you in the Midwest, there's some little different terminology, some different applications in Denver, St. Louis, Kansas City, some things in Chicago, Detroit. But again, East Coast, Midwest, all the way to the West Coast, there are some similarities, but there's also some very significant differences that revolve around the construction methods and materials, era and vintage, again, row frame, row houses, and other distinctive architectural treatments, features, and conditions that revolve around those. So it's not one size fits all. And there are some things that, unfortunately, none of the textbooks get into because they do not dedicate the level of detail that really is necessary to get into for those types of conversations. The other particular aspects when we talk about these particular buildings, I'm going to get into some of my detailed elements here. Again, we talk about footprints. The actual footprint of a row house is relatively small, scalar. When we talk about the footprint in terms of width versus depth, there are some other regional or city-based differences. So you should also recognize too that there are, if I go into New York City, if I go to Boston, Philadelphia, Baltimore, DC in particular, where the origins of the row houses as they first made their way into the United States in that mid to late 1800 period, especially with the explosive growth and applications of row houses at that time, some of these configurations and layouts, they actually had some very specific types of terminology. They had a certain term, and that term and titling would also indicate sometimes the square footage and size, the width, the numbers of rooms that would be present, the orientation of stairwells, the height, the absence or presence of cellars or basement areas, the stoops, the location of the stairwell, whether it be a single run stair on one side or the other upon entry from the entry vestibule or entry portal, what one could expect for the orientation of rooms, the number of rooms, bump outs, as well as the number of floors. So we've talked a little bit about that. We actually talked extensively about some of those features in our first series when we rolled this thing out back in 2020. But Philadelphia has its own terminology, the Baltimore row house, as well as the subsets of types of row houses, whether they have porches, whether they have bay windows, whether they be the type of pure row house configuration. And by that, we typically just talk about the 12 to 15 foot width row house, party wall masonry construction between occupied units, sometimes a bump out, which is pretty common in the rear, a cornice, a single run, single sloping roof system from front going to the rear, from the Alpha side going to the Charlie side. Single run types of roofs, single sloping type of roof configurations, certain window treatments and orientation, as well as the types of brickwork, brick treatment, and the application that was very, very common in a certain era of time that especially on the East Coast, and it certainly started making its way across into the Midwest and other areas of the country, but its originations occurred in Baltimore in 1937, where the applications of a coating material that was applied to these older types of structures to give them a different type of aesthetic, meaning a visual type of an appearance that created some other significant challenges. And one of those things dealt with a branding, and that brand was actually called Formstone, Formstone, originated in 1937, originated in Baltimore. And I'll mention a little bit more about that as we continue on in our conversation. But that in itself has a very specific application in terms of identifying that it's number one present, and also recognizing that it might have a contributor to influence decision making on the fire ground, because we don't have the ability to fully identify and determine the level of risk of the infill construction, especially on the alpha or number one division on the street side, in terms of the integrity of the brickwork that is part of the infill that forms the facade on the front of the building. Commonly, we find this formstone being applied to the front facade or front face of a building, and that in itself gives a different appearance of a material, but also ends up masking out the integrity potential of that building. That formstone had a significant influence on the operations at the triple line of duty death in 2020 and 22 in Baltimore. And unfortunately, that information was completely omitted in the NIOSH report. So let me step back for a moment. One of the things that I was able to provide as part of my engagement with NIOSH as a subject matter expert and technical advisor, we ended up, or I should say, I was reached out to and early in the phases of that event, and came on board as a SME with NIOSH to take a look at the insights of both the building construction and its performance for the rowhouse fire and the subsequent collapse that occurred at 205 South Stricker Street in Baltimore. As I got involved in that investigative analysis and looking at the predictability of that building performance, a couple of things became very, very apparent that were eventually captured in a very comprehensive report that was issued out. That final report was actually published or sent to NIOSH. It was dated on the anniversary of the event. It was dated January 24th of 2024. And there is a little bit of that information that was captured as part of the appendix in the final report for the NIOSH report that was published again in May of this year, which was again report F 2022-01. 3 firefighters die and another seriously injured during the collapse of an abandoned, derelict, 3-story row house fire in Maryland. And as I mentioned, just from a disappointing standpoint, there was very little that was presented in the final version of that report, for whatever reasons, that did not get into some very pertinent and very specific building features that affected the building's integrity, were certainly suspected to, and with a high degree of probability, may have very well have contributed toward other factors in the building's inability to sustain the degree of fire involvement that was present in this abandoned derelict structure, previous fire conditions that affected the building's integrity. But it's highly probable, based upon the information that we uncovered, that there were contributors there, not only in this building, but in other buildings that are part of that same block across the street, in that battalion, and certainly in other potential areas around Baltimore City, that certainly may influence other subsequent decision-making and other subsequent building risks in similar structures that have these characteristic inherent conditions that now may not be identified. So one of the things that we're looking at is furthering along, and we haven't figured out how we're going to actually proceed in this, but I would certainly like to very much make our analysis report public. We're going to work through some avenues of communications that need to be addressed formally for appropriate reasons with some of the affected organizations first and foremost, and then secondly, we'll identify an avenue to have this report, the analysis report of the building, published in its entirety, because it does get into some very specific building features that are unique and that one needs to look at. So when I talked about earlier on in our conversation here, that one has to be able to comprehend what it is that you're seeing out in the field. In other words, you're in the overall stages of a fire in a row house, and it's just another job, right? You're going in, you're opening up the ceilings, opening up the walls, looking at different features, talking about the success or challenges that that incident may have, or not even talking about anything at all, just mopping up, just going through another evolution of an operation at a row house fire, right? Dime a dozen, we have them continuously challenging us when we show up on scene. And for many of you, row houses are the bread and butter of your operation in your municipality, in your first due, and sometimes in your entire division or city that you represent and provide protection to. And there becomes the problem. We have such a degree of frequency in our buildings that we are not sometimes recognizing and seeing some very subtle conditions that may be inherent features in that building that may influence other decision making and other operations tactically and operationally at the strategic command level that have a degree of importance. And because we don't know what it is that we're seeing, that, and I'll just say this, I'll correlate this back to a significant event that occurred again in a previous fire. These were some of our insights when we got into a conversation and discussion. I'm just pulling some information back out. And this was the fire that occurred on January 6th of 2018. This was operations that were conducted at 2240 North Colorado Street in the city of Philadelphia, resulted in the line of duty death at the time of Lieutenant Matthew Letourneau, who posthumously was promoted to captain. But Captain Letourneau lost his life while operating in a very inconspicuous, nondescriptive row house fire, and under some very challenging weather-related conditions. But inherently, there was a very predominant feature in that building that was a direct contributor or subsequent contributor to the structural collapse of that building. So although the building in this instance had some significant weathering and exposure to environmental factors that affected the building's integrity, structural integrity of wood and structural supports, the presence of hoarding condition or heavy content conditions, one unique feature that was present as a result of adaptive reutilization of that building. So in the late 1800s, as gas service was being applied as gas service was now being readily available to these occupiable row houses in the city of Philadelphia, as the gas service was being brought in from the streets into these occupancies, floorboards were being pulled up, structural elements of the floor joists were being modified to allow the setting in of these cast iron piping that would bring in the supply of gas service to allow for both heating and lighting of the structures. In this instance, the center line of the span of the floor joist going from bearing wall to bearing wall, 15-foot span, 7.5 feet at the center line. The tongue and groove floor conditions on the number 2 floor were pulled up, and a small notch was laid in at the center line from front to rear of that structure. So front being the facade, the exterior portion on the alpha side, and they were being brought in at the number 2 floor line, brought in from the street side, spanning from front toward the rear where the kitchen was located in a small bump out, and then dropped into that area to provide service both to the number 2 floor and the number 1 floors. That small notch to allow the 1-inch pipe, cast iron pipe, to be brought in was at the worst possible location. that notch at the center line resulted in the ability for that floor to compress in an unrestricted manner, resulting in the separation and the tension being applied at the bottom of that floor joist. So compression at the top, the cast iron was present in there. We make that notch in the worst possible location, coupled with the species of wood that was being utilized in that structure, and we end up having a series of conditions that resulted in a very catastrophic failure, and very much so an unheralded type of condition. In other words, that particular floor collapse was at the center line, which resulted in a almost completely symmetrical V-shaped collapse from both the Bravo delta walls, the separation of the floor joist at the wall pockets, and a centerline collapse, perfect V-shaped collapse that occurred, bringing the floor conditions down, eventually trapping Letourneau in that location. But again, it was not the first time that a fire had occurred in that type of structure that inherently had this modification that occurred over 120, 130 years prior. And subsequently, over that 100-year span of time, other buildings had been overhauled that had similar features. However, all of the associated factors that went in and that were contributors to that collapse were obviously present at the Colorado Street fire that came about in a manner that catastrophically resulted in the collapse. But knowing that other buildings, the adjacent exposures, other buildings behind the structure on other blocks within that same city block, again, this is inclusive of a significant high number of unidentified buildings, but significant other buildings that very potentially, with a high degree of probability, have similar inherent deficiencies that, when the right set of circumstances align, could end up becoming precursors for adverse compartment conditions regarding fire suppression, or may lead to unexpected structural failures that could be very, very catastrophic in nature. So those are some of those features. That in that instance too, when we talk about methods and materials of construction, what was identified during the overhaul and actually during the initial stages of rescue and extrication of Captain Letourneau at the time, firefighters and officials identified, and subsequently when we got into the investigative analysis of the building, both in terms of the internal portion of it at the department level in Philadelphia, and when we were working with the health and safety division, and then subsequently when I was involved with NIOSH, in both instances we found, and through the conversations that occurred, they kept talking about this lightness of the wood, and that lightness of the wood was something that eventually piqued our interest very significantly. And when I actually put my hands on some of the 2x lumber at the time, it was very, very noticeable. And at first, my first impression was, again, loss of moisture content due to the age, deterioration of the building. Again, the building was built in the late 1880s. With that type of longevity, it's very common to find the moisture content of these of the wood components to be to evaporate, again, just through aging, the life cycle of the building, freeze-thaw cycles, heating, and so forth. Moisture content is lost. The wood dries, it ages, and that drying effect results in a much lighter type of wood. It also makes it highly more prone toward early ignition, fire propagation, and very rapid deterioration through the pyrolytic decomposition process. So when I have dry wood, for simpler statements here, I have dry wood, it's easy to ignite, it's easy to sustain combustibility, and it also ends up propagating and extending and charring at a quicker rate. I start having that charring, I start losing the material, I start affecting the structural integrity of the building, and if it's a multiple combined series of joist conditions at the roof, the floor line, the subsequent condition is I'm going to have a collapse, I'm going to have a compromise, something bad's going to end up happening. So in this particular instance, and I'm just queuing up some some of my data here for those of you that are watching or and so forth. So in this particular instance, again, the age of that particular building was around the 1880s criteria or period, or circa 1980s. The floor joists and the ceiling joists and the roof joists were 3 by 8 inches or 3 by 8. As was classified, it was a 3 by 8 joisted piece of material. But again, once the suspicion about what's going on with this wood revolved around some other questioning attitudes that we had, the wood was subsequently analyzed by NIOSH and subsequently identified by species, and that species of wood was eastern hemlock. That eastern hemlock, as we furthered our investigation and actually went into some of the earlier books that were being written in that period of time, which we actually have on my personal library shelf, those books identified some unique characteristics about brick and joist or wood frame construction. So this is inclusive of both row framed buildings as well as row house buildings or any buildings, but especially when we have structural components in these buildings that rely on the integrity of spans and other components. So I'm going to read this verbatim. So eastern hemlock, the wood is moderately lightweight. It's only about 28 pounds per cubic foot at 12% moisture content. So the weight of that material is actually going to be less with a subsequently decreasing degree of moisture content, especially if we're in the 2 to 3% range. It is moderately weak in bending strength, moderately strong in end compression. It is low in splitting resistance, and average in nail holding capacity, moderately low in overall strength, moderately stiff, and moderately low in shock resistance. And the important item here to note, again, I would encourage you to take a look at the Letourneau line of duty death. Again, when we talk about the report, and actually hold on a second, let me make my notes here referencing. So when we talk about the events surrounding the 2018 line of duty death report. So I would reference you back to NIOSH report F 2018-03. The occurrence was January 6, 2018, and resulted in the single line of duty death of Captain Matthew Letourneau from the Philadelphia, Pennsylvania Fire Department while fighting a row house fire that subsequently had a very significant and catastrophic V-shaped floor collapse within that 2-story row house. So in that report, we get into some very specific details concerning the construction features that we're trying to revolve around here in our conversation. But one of the series of images in that report that were very telling was that once the front facade was removed, you could actually see the manner in which the floors subsequently failed from the front of the building going to the rear of the structure. And the failure point, which was more pronounced, was in the midpoint of the building, around the center point where operations were being conducted. And you'll actually see the visuals where the floor joists are either in a compromising condition. So the most evident floor joist spanning from the Bravo to the Delta side at the front of the building shows some signs of cracking. But as one looks at the parallel floor joist from front going inwards to the building, you can see all the way up to the point in which the V-shape collapse ends up occurring. There is a very pronounced sequential degree of splitting. So as we got closer to the comprehensive collapse, catastrophic failure collapse, the wood has splintered and actually split, which is very much in line with the characteristics of this wood. And here's the other smoking gun that came into our research that, again, was being written by the textbooks or the architectural books, which were few at that time, but the architectural books of the late 18 and early 1900s said that the eastern hemlock species of wood was great for being utilized in the application of lath for plaster and lath construction within the buildings, but should not be utilized for structural support within that structure because of their weaknesses, the inherent conditions, the low splitting resistance, the weight carrying strength and capability. So what ended up happening here? So when we talk about shoddy workmanship, that's more common here to the modern era of construction that we always associated with. We have builders in the late 1800s or the 1880s that instead of going further and deeper into the forest to get the right species of wood to be utilized for structural supports, especially in the floor systems within the buildings, they went out and were confronted with the most easily and readily accessible species of wood that as they were developing these neighborhoods of row houses and they were going in the immediate forests that were surrounding that, the most readily available type of wood that could be cheaply cut down and brought back into the city and again dressed and eventually put into the buildings or taken to the sawmills and then subsequently dressed was eastern hemlock. So eastern hemlock was readily available, cheaply. It was the worst possible wood that could be utilized, and there are literally thousands of buildings within some geographical areas in the city of Philadelphia that are utilizing this type of species of wood that are inherent to the buildings, that also have inherent decision-making considerations based upon other factors that go into the buildings that certainly very well may influence operations at the tactical and certainly at the command level. So just a couple of quick notes on that. It's also interesting to note, too, that when we talk about construction features, that commonly, again, when we have bearing walls and party walls, bearing walls are normally going to be freestanding walls. They're going to be adjacent to each other. If they are in a condition in which we have a bearing wall, they commonly do not end up sharing the structural loads on either side of the occupancies. A party wall is exactly as it's described. The party wall is a singular wall that ends up sharing the structural support of the occupancy on either side. So if I have my occupied unit in front of me and I go to the Bravo exposure, that Bravo exposure's floor system as well as roof system very well may be part and utilizing that singular wall and having a common bearing area within that pocketed or corbelled area of that wall that's adjacent to it. And the same thing would be for the delta wall. That delta wall for that occupancy would share the delta exposures structural supports that go back into it. So I would encourage you to take a look at, again, some of the insights that are drawn out of the Philadelphia, Colorado Street report. I would have you take a look at the 2012 double on a duty death, again in Philadelphia, that dealt with a building of heavier timber construction, in which we provide and give you some insights on the what's called the bevel cut or the fireman's cut that was introduced in 1892 and codified in 1894. So we can have buildings as the Colorado Fire building had in 2018 that do not have a beveled or fireman's cut. The floor joists are right angled. They fit and pocket directly into the wall area. And if they do fail, especially on the end units, you will end up having a wall collapse. When we have the beveled cut present, the bevel cut results in an inherent condition in which the floors will fail and result in the outward or inward movement of the floor systems. They will fall inward without affecting the integrity of the wall. So when a pocketed floor joist or ceiling joist with a beveled or fireman's cut, which is a slight angled cut to it, is embedded into a pocket and is bearing in a party wall, the party wall's integrity is more likely to remain intact versus being compromised by the mechanism of collapse of the failure and the downward movement of that floor's condition. So in the Stricker Street fire and collapse, that building did have a firefighter's cut or fireman's cut or bevel cut to the building, but the unique factor in that particular building, which I'll mention here in a moment, was all directly related back to the thickness of that particular building. So again, the The type of construction and the orientation of bearing in party walls is important. Typically, you will find the floor joists that are in row houses to be parallel to the street and parallel to the rear alleyway locations. And there may be some slight differences, especially with bump outs, but in the inherent primary aspects of our row house buildings, normally the floor joists are going to run parallel to the street area. And again, they're going to be supported at the Bravo and the Delta sides. There may be some differences in the manner in which the roof rafters, especially with inverted roofs, are located. Those roof rafters, again, may be pocketed into the corbelling or may be located into the coping stones and the parapets that may extend from front to rear, but they also may go at a 90-degree angle, and there may be a different degree of support, especially with a cross beam that goes from Bravo to Delta at the cornice level. So I'm just trying to indicate that there are some features in the buildings that at the cornice and at the roof line that might be consistent with certain building characteristics, but I think one of the most important things that we've got to have a conversation on, or that we want to present here in this particular episode, is just some unique features dealing with the floor joists, ceiling joists, the presence of plaster and lath or other types of compartmentation conditions, the types of wall configurations, the bearing, non-bearing, and party wall locations and conditions, and then the types of infill construction on the front rear of the building, and more importantly, the absence or presence of the formstone that I want to make sure we cover and discuss. Some of the other features here when we talk about row houses, again, absence or presence of dormers, mansards, the sloping conditions. Most of our row houses will typically have high point at the front near the cornice line running from a single sloping condition from front to rear. There's going to be potentially some other peaks or gables that may be present, but more commonly you'll have some architectural features depending upon the size of the building. When we get into these 2 or 3 stories type structures, or 4 stories in some instances, but especially with the 3-story buildings, roof configurations, voids, and other concealed areas may be more ornate. Thus, the types of mansards, the types of occupiable spaces that may be up above, as well as the areas for communication and fire extension horizontally between occupiable units or from unit to unit. So whether it be occupied or abandoned, again, there's a very likelihood that you may have very rapid fire extension from wherever the primary unit may be, again, to the Bravo and to the Delta sides very rapidly, which requires again, a variety of different responses in terms of the types of tactical approaches, especially with ladder and truck company operations, to provide separation for extension, very, very rapid extension along that entire row, whether it be at middle of the row going in either direction, or from end of row or end of group going in the opposite direction, which again may be unabated. But we'll get into some of that conversation a little bit more in our tactical episode. So again, the presence, the sizing, again, typically 2, 3, and upwards of 4 stories. 2 and 3 are the most common. Presence of dormers, mansards, the slopes, the peaks, the gables within those types of areas. Cornices, again, cornices more often than not, because of the brick and masonry construction, you would have a brick infill type of construction, meaning the infill material that's forming the facade or the front of the building is not going to be, in many instances, greater than a single or maybe 2 widths of brick. So again, I might have a 4-inch width of brick, which is only a single width of brick that forms the infill. It's non-structural. It's there just primarily as an enclosure wall for that perimeter, front and the rear of the structure. So thus you might end up having a brick cornice. It's also not uncommon to have wood cornices or tin or galvanized metal that's been applied over the wood material that may be present. And again, that might be something that one has to be aware of. Again, the manner in which that the cornice is attached to the building, whether it be and in some instances, these were pre-manufactured and the modular types of units that could be ordered off of catalogs in that period of time and then subsequently attached to the building. There may be attachment, deterioration that may occur. It's not uncommon to have a substantial portion of a wood cornice that becomes unattached, that ends up collapsing as companies are moving up the stoop. There was a near miss that occurred a number of years ago in Brooklyn, in which the engine company was making its way up the stoop, getting into the parlor or number one floor area, and the cornice, due to auto extension from the upper floors, hit that cornice, subsequently resulted in some deterioration, non-load bearing capability of structural integrity factors, and the entire cornice ends up coming down on the company as they're working at that stoop, making entry into the interior. So it's not uncommon to see that. Additionally, in many jurisdictions, again, the older brickwork, because of deterioration and other costly aspects to either repoint or provide structural stability, loose brickwork that may be present, it's not uncommon to have either plywood, OS&B, vinyl, or other types of material that's applied to the ornate aspects of the cornice and just have them covered over. So we have this false facade or treatment that's been applied. It's all this aesthetics. It's very, very common if you've ever driven through the rowhouse areas of Philadelphia to see this variation where you can see an entire row. And again, I see the good brickwork and I can see bad brickwork. And I go a little bit further on down, I can see the vinyl that's been applied to it, that the cornice configuration and orientation is still present in terms of a particular angle and configuration, but it's been covered over. It's been covered over with, again, some type of siding material, vinyl, plywood, OS&B, it's been painted, whatever cheap type of material. Sometimes it's fiberglass. It's a whole variety of things, but it's very, very, very common, certainly in Philadelphia, to see these types of treatments along those areas, and sometimes they're inherent from unit to unit that creates an entire facade that has the potential for fire extension and also potential for unchecked conditions to affect building integrity that result in collapse zones being present from those locations. So just a couple of quick notes on those. And then lastly, the presence of bump outs, both in the front and the rear. So these structures, when they were originally built, typically will have extensions that were put into the building, either inherent as part of the building or bump outs that were part of these building renovations that occurred in other decades of time as the longevity of that building continues on. Porches, cellars, basements, stoop conditions. Sometimes those porches may be very extensive. The orientation and the type of architectural treatments that may be present. Again, there were middle to higher end types of row houses that go from the fundamental of very limiting types of conditions. So when I take a look at some of the original row houses that were meant for a certain class and economic basis of factory workers and so forth, they are very simple in terms of their style, design, the types of window treatments, and even the types of lintels and sills that may be present. But again, they all have a certain type of configuration, orientation, architectural treatment, and style in terms of the brickwork that would be present, the types of treatments of the cornice areas, and then also the configuration and the layout within the areas of front rooms, rear rooms, and the location of stairwells, either in central core stairwells at a right angle or single run stairs that would be present on either side of the entry point at those stoops and the entry parlors that would occur. So there's some other features here that we're going to get into when we talk a little bit more about the tactical approaches, front rooms, back rooms, and so forth. The footprint of these buildings is pretty consistent. It is highly predictable, and sometimes they're self-revealing. And again, for many of you guys that have experiences in one of these buildings, you certainly should understand it and know what I'm talking about. I think the other part here, when we talk about modern construction, so we've been really harping a little bit more about the older construction features, but again, pop tops. It's not uncommon to go into metropolitan areas, and it looks to be the bottom part of the building looks to be vintage heritage construction from back in the day, and I've got what appears to be new construction for sometimes one or two stories on top of that building that are expanding vertically. So it's very difficult to expand a building from side to side due to the other row houses that may be present. Street configurations in the front limit that, and sometimes the lot lines in the rear will also provide some extreme limitations. So some concepts were pushed, codes were modified in a couple of metropolitan areas here on the East Coast in a number of years. Again, here in the 2000 era, what we call pop tops occurred, and where they take the roof system off. Sometimes the entire upper floor is removed, but more often than not, roof systems are removed. A floor deck is applied, and it's not uncommon to find 2 or more stories of new construction that are rising vertically on top of the structure. So now the question becomes, what are the integrity of the structural supports? To what degree were appropriate codes and ordinances followed? What was the integrity of the bearing wall or the party wall that many of these structural supports were provided or are providing? Were there other additional structural features put into that building to help provide additional support, the dead loads of the building in conditions? And again, there's a number of collapse considerations and factors that go into these buildings that have yet to be fully identified. And we're just not having the conversation. Thus, the reason for this particular series, I felt it was very important for us to revisit what we originally started talking about back in 2020 when we rolled out our first 3-part series, and subsequently what was envisioned just as a couple of part series here in 2025 to get into some of this conversation. The more we got into it, and especially with the feedback, our first 2 episodes resulted in quite a bit of feedback from many of you, our listeners, talking about, hey, let's get into some of these other conversations. So inherently, what we ended up producing is this sort of bridging program where we're talking a little bit more about some construction to bridge the gap between our first 2 episodes and then our conversations on the tactical approaches here in our next episode. So again, with new construction, pop tops, also the fact that you may have hybrid construction that utilizes both old and new, and sometimes, yes, you might find the entire interior gutted out, all with new engineered structural support systems. It's not just lightweight engineered components, assemblies that are part of the systems. You'll have entirely different hybrid types of engineered structural components, a variety of different floor systems, spanning conditions that may be present that sometimes are going to be very evident. They're going to be self-revealing. You go and you see the middle of the row or middle of the group, and you've got an entirely new structure that's standing out. And sometimes it goes up 4 or 5 stories, and I've got 2-story occupancies on either side, and I got a 4 or 5-story row house that's entirely been reconstructed, a new facade, and it's standing out like a sore thumb in the middle of that row. So many of you have seen these patio areas up on top of the roof. There's a whole variety of other features that we could get into and have a conversation of that are going to be present, along with different facade materials and so forth. But again, we'll take a look at that in terms of some other conversations that, again, are a little bit limiting here as we get into our conversations here on again, a little bit of the insights on the row houses. A couple of things here that I just want to get into. I'm going to go through some quick notes here that relate back to it. Talk a little bit more about a couple of row house items. And again, we're already encroaching on the 60-minute time frame, but I just want to talk about some uniqueness and variations of the row house. And I want to give you a little bit of a verbal insight here on the what was I going to say here? On the Formstone construction here for what's evident and present on many of our buildings. And again, it played a critical role in the Baltimore City fire because it resulted in not having the entire facade of the alpha division of that wall failing and falling on the rescuers that were diligently working to try to extricate and remove those that were entrapped as a result of the complete pancake collapse of the interior of that structure in Baltimore, when in fact the facade very well could have collapsed either inward or in some type of a curtain fall collapse. But because of the entire structural support pancaking down from roof all the way to the first floor and into the basement, the resulting unsupported wall on the alpha side, since it had no structural integrity and it is in an infill wall, the brickwork in that wall was only held in place due to the Formstone material that was applied to the outside of that material. That outside stucco, along with the manner in which that Formstone was applied, actually resulted in maintaining the integrity of that entire 3-story brick facade and kept that from potentially resulting in significant firefighter injuries or more serious conditions occurring during the conduct of the rescue operations in the very early stages immediately following the collapse and the entrapment. So I want to make that information evident. And again, unfortunately, none of that information got into the final NIOSH report, and thus the reason we need to get that information back out to the American Fire Service. And additionally, before I end up just bypassing again, when I talk about and I mentioned some things here about the brick bearing wall and party wall. So typically, when I have a bearing or party wall, a bearing and party wall at a minimum should have a double width wall constructed. In other words, a single width of brick is commonly 4 inches in width. A double brick or double width bearing or party wall is typically going to be 8 inches and is comprised of 2 side-by-side bricks that run parallel to each other that are connected and reinforced to give us a freestanding wall that relies on the integrity of each side's floor joist to provide stability. In other words, if I have, many of you have seen this, so you've got a series of row houses, right, from one end of the block to the other. And at some point, you've lost a couple of those middle of the row buildings, or you've lost some occupancy that's in between other units. So all I'm referring to here is that you have a series of row houses, and at some point you have an empty lot that either the delta side on one side of the unit and the subsequent Bravo side of that other end of that vacant lot, those walls, if they were party walls, are what we call open-ended walls. Those open-ended walls, especially when they're party walls, have lost the ability to maintain their integrity due to the absence of the floor joists that would have spanned and provided structural support. It would have provided lateral support. Many times in jurisdictions, you may be going down the street, you'll see some types of shoring that's been applied to one or both of those walls on either side of the open lot. They are there to keep those walls from pushing outward because of the downward directional force of gravity wanting to push the building down. Those walls want to push outward, and when they do push outward, we end up getting a call for a resulting structural collapse of one of those walls, or sometimes a pancake collapse, but sometimes that wall will blow outward. We'll end up having 2 or 3 floors that are now lean-to collapses. We'll find victims on the debris pile, whether they be internal or have ridden the floor movement and are located somewhere in that surface material that result in our immediate rescue efforts. So there's some things here that, again, are very, very common that we need to recognize, that based upon the building's configurations, orientation, these different presences of certain features and conditions play out into subsequent potential responses. And then when they do lead to a particular response, we need to understand what some of the mechanism of collapse was, how they contribute toward maintaining safety, additional risk factors that need to be identified. You need to understand the construction of that particular building. So a couple of other items here I just want to make mention of. So let me go back. So in the Baltimore City collapse, if I'm expecting to find a 2-width brick bearing or party wall, unfortunately, again, this information did not make its way into the report either. We identified that, and again, there were subsequent collapses that occurred during this operation that are not discussed very much in the report, which we will talk about in our final installment when we discuss some of the insights from the 2 most recent Baltimore City reports in our last episode here on our row house series. But it was interesting to note that the party wall that was on both the Bravo and the Delta side of 205 Strichter Street was only 4 inches thick. And that 4-inch thick wall was supporting the floor joists from both the 205 and subsequent adjacent occupancy on that particular street. So it was only 4 inches thick, and that 4-inch thick wall was common to that particular structure. It was common to the manner in which the building was constructed in that period of time, And furthermore, when we identified the aspects of that, when those particular types of buildings were being built, and the people that came across the pond, came across the Atlantic to build these buildings in Baltimore, they brought with them the methods and the materials, the process and the methodology for building similar types of structures as was common to build these buildings in that 1880, 1890 period in London, only utilizing a 4-inch thick brick wall. So when we look at those things, there were some very unique factors. Unfortunately, we are discussing them here in the context of our pod and webcast, and unfortunately the missed opportunity of not having that information captured within the context of the reports. So thus, again, the importance of getting some of this more of additional information presented in some manner and published out there for the fire service to be able to recognize. I'm just queuing up a couple of quick notes here as I'm going to try to wrap the portion of it up here in the next couple of minutes here, only because we've gone a little bit over. And again, this may result in some further conversation in our other subsequent episodes. So originally we intended to have a 4-part series. These episodes have gone to 4+ to 5, and very well may lead to a 6th episode here. But I will also, again, keep everyone abreast through social media of what we may end up doing here with some of the information that we want to get across here with the publication of this or some other documents. So we're going to reach out to fire engineering, going to reach out to some of the other affected groups, see what the appropriate manner may be. We want to get this information here in the hands of the primary groups and the fire department agencies. But again, I think it's important to, especially since the analysis that we completed is very richly illustrated, a lot of this information is very pertinent to our conversation and the discussion to gain the insights on row houses that will subsequently help you do your job at the tactical task level, company officer level, and certainly at the command level. We need to gain some of these insights, thus the importance of why we made reference to these other reports, again, from Philadelphia, from Wilmington, back to Baltimore, and so forth. So one of the things that I'm just going to make reference to here, again, is the development of this facade system. It's a parging type of material that was actually a treatment that was applied to the facades as a aesthetic treatment. And the brand name, again, was Formstone. It was primarily a maintenance-free alternative to the low-quality brick that was commonly used in construction in many early row houses. And again, originated in Baltimore. It was developed and promoted by a Baltimorean by the name of Albert Knight. And it was first developed in 1937 and subsequently went into being utilized all throughout the East Coast and certainly made its way throughout the Midwest in the United States. This brand of Formstone, again, was patented. I think we'll maybe actually put out on social media here at some point some insights on it. But again, Formstone was directly attached to the brick masonry wall. It was applied in 3 layers of cement-based concrete. There was an anchored, preformatted galvanized metal lath that was attached to the existing brick facade. Sometimes it was mechanically anchored with nails or other materials, but it was typically a common economical way to just nail that directly into the brick and many times into the mortar that commonly very well may have been, again, a sand lime mortar, which is inherently another degree of deficiency. So once that was attached, then the first of 3 layers of cement-based concrete was attached to it. That first layer of cement typically was a 3/8 to a 3/4 inch. It was scored before it was dry to provide the ability to attach. The second layer was applied, and that was typically between 1/4 of an inch and 3/8 of an inch thickness. So that was the second layer. And then the top layer, or the finished layer, was between 1/4 of an inch and 3/8 of an inch. That was applied while the second coat layer was still being set, or before it was hardened and was still sort of plastic. When that finished layer was still wet, it was hand sculpted, and that's the important part here. It was hand sculpted in the various shapes of stone. That finished layer was also colorized to make it look like or become or used to imitate stone, and it was texturized with a number of different tools, different textures and so forth, to look at like a variety of different stone treatments. That false or fake facade had sometimes the appearance of cut or masonry stone, or ashlar stone, or dressed stone was typically the applied. So it made these buildings look like something more than they were. They made them look like a richer type of building. So when applied, it gave you this appearance, and that colorized appearance was very unique to the building. And again, depending upon who the applier was and the builder was, sometimes you would have some similarities in terms of the hand sculpting. But all of that hand sculpting and the treatment and the location of the joints and so forth was all done by the individual appliers. So not all buildings had a similarity. They would have some similar appearances, but they were all very, very unique. But that additional type of treatment, again, was primarily in working class types of structures. It was very, very commonly associated with the Baltimore area, although it made its way all the way, again, into the D.C. area, Baltimore, Philadelphia, all the way up the East Coast, the New Jersey area, New York City, all the way up to Baltimore, and many other areas throughout the United States. Other similar types of treatments were very, very common and were very much applied. It was also, again, just utilized as an alternate for masonry restoration of older row houses. So it's very, very common to find this material present. So when applied to the building in terms of its application, these can also lead to both inherent structural failure conditions. In other words, that additional weight of that material may result in a premature collapse of the front of the building, or in the instance of Baltimore, it actually helped keep that facade in place. So here's some insights that I'm going to give you here. So when the interior structural floor systems all gave way and collapsed in a pancake collapse, the only thing that was left was a 4-inch wide brick wall that spanned from the street level of the basement location or at the stoop location all the way up 3 stories. So I had a 3-story freestanding, unsupported brick facade. That brick facade had inclusively to it approximately 307 square feet of net surface area. That equated back to approximately 13,000 pounds of estimated dead load. That Formstone system on that 307 square foot had an additional dead load of approximately 5,600 pounds. So, when we take a look at the total conditions, we have upwards of 18,500 pounds of dead load that is part of that freestanding wall that was present. So there was about 24% open wall areas that were present. So there's not a lot of structural integrity. Fortunately, as the companies are operating, Baltimore City is operating within the stoop, within the sidewalk area, trying to make entry through the door in the collapse zone that's immediately on the other side of that facade, going from alpha to the interior. That stone, or the Formstone material, as it was applied to the brick, maintained the integrity of that 3-story wall until they subsequently deconstructed it and removed the facade in a controlled manner to eliminate the level of risk and allow the operations to continue in that subsequent condition. So again, I think we will make, directly as a result of our conversation here on our podcast episode, we're going to make available, I think, a couple of screenshots of this. I'll just make some notes on it. I'm going to put it out on our social media pages, both on Fire Engineering, on our Buildings on Fire, on our Facebook pages, as well as on Twitter, and get some information that is excerpted out along with a cross-section. I've got some great graphics that show how this material is applied and how it's very evident out there. If you've never heard of it, I can guarantee you that now, tomorrow, if you go out on the streets, or tonight, you go out on the streets and take a look at some of your buildings, you're going to identify some features, and very well. Again, take a look at edge conditions, take a look at some of the treatment around windows and doorways, take a look at the edge between end of units and so forth. And you very well may see the separation of that particular material and so forth. So I'm just looking through some additional notes here. Again, there's a lot of other material that we wanted to cover that unfortunately, again, 90 minutes have gone by that we have just scratched the surface, talking a little bit about some construction. I wanted to get into some inherent features that are typically present in there. I think we'll post a couple of materials. We may very well do a small little snapshot podcast next month on our next episode that leads into it. But and if we don't, we'll find a way to get some more material out there, whether we utilize this platform or get some other sound bites out there. We may very well utilize some of our. We've actually been talking about having these small little 1 to 2 minute little not podcast, but little video clips that we're going to do. Maybe we'll end up doing that. That ties back into this. This might be a good way to get everything kickstarted and out. So in the upcoming couple of weeks, we've been talking about this for a number of months, all the way going back to last year, about our video series and so forth. We are still struggling our way to try to get some of those things finished off and be able to be publication ready, to be able to actually get out into the media world. So it is what it is. It's very, very slow in our production, but we are very confident that we'll get something out there certainly by the middle of the summer. The middle of the summer is already approaching, and we may tie some of this stuff in as I look at my other screen here for those of you that are watching me on our webcast and so forth. So just a couple of things. Let me just close by. I'll just say this. The small compact size of the row house structure, when impacted by unstable or compromising structural stressors, may not have the resiliency or the resistance to overcome and recover from those conditions, or allow for load transfers and still maintain its structural integrity, stability for operations. And these are some of the things that end up directly leading to and resulting in the types of conditions that we end up having in our row house fires. So again, I'm just taking a look at some of my other high-end notes here that I wanted to cover. But again, I've got too many notes here that I want to try to address. But I'm thinking here too. Here's another quick little note here. Again, although the size, the footprint, and the design of row houses have lesser fireground complexities than typically encountered with larger size and more complex Type 3 buildings and occupancies, nonetheless, company and command level sensitivity of potential compromising and catastrophic structural conditions or fire dynamics that may be present within the building that may evolve with the fire incident that do not clearly have identifiable operational benchmarks or prompt declarations of fire conditions under control or extinguishment may have diligent and timely monitoring of that decision-making that may affect operations. Predicting an adverse fire condition or potential structural collapse is one of the most challenging tasks facing an incident commander at a fire scene. Usually the lack of information on the construction of the building, the fire size, the fire location, the fire burn time, and the conditions of the building, the fuel load, and other factors may make the task nearly impossible. But again, there may very well be a series of indicators and other building intel and learned predictability performance that may give us that tactical edge. So again, I think just for the interest of time, we're at 90 minutes into our episode, and we've only just scratched the surface talking about some of the construction features. So we will post some additional information on social media here pertaining to some of the information on the Formstone, especially the information on the facade. I think that's important information to get out. We'll talk a little bit more about some of the things that we're going to get out there. I would encourage you to at least take a look at the most two recent NIOSH reports, F 2022-01 for the Baltimore City Stricter Street Fire, and then also F 2023-11 for the double line of duty death, again, in the city of Baltimore. So with that being said, again, I want to thank you for listening in. Until next time, companies are in quarters and off the air. Stay safe, but keep in mind there's a job being worked somewhere in the streets, in your city, across the country, and around the world, doing what we do best in being who we are, and that's firefighters. So thank you very much for listening in on this edition of the Buildings on Fire podcast with your host, Christopher Naum. Look forward to talking with you next time around, next month in July, for our next episode, talking about tactical insights, command insights on the row house occupancy. Thanks again. Stay safe. We'll see you next time.